So now we'll start graphing quadratic functions. So the graph of the quadratic function, which is f of x equals a times x minus h squared plus k, has vertex hk. The domain of the function is negative infinity to infinity, all real numbers. And if a is greater than 0, then the range is k to infinity, making k the smallest y value. K is the minimum y value in the case where a is positive. But if a is negative, then the range is negative infinity to k, making k the maximum y value. So let's see. Let's go ahead and graph this function. They want us to identify the vertex, the axis, and all the intercepts. So the first thing I'm going to do is I'm going to take the independent variable of the squaring function here, which is x plus 3. I'm going to take the x plus 3 and I'm going to set it equal to 0 to find the axis of symmetry. That axis is a point where the vertex is going to be plotted on. So the vertex lies on the axis of symmetry, and the axis of symmetry is the line x equals negative 3. So I'll go over here and I'll draw the axis of symmetry. I'll just make a dashed line to represent the axis of symmetry. This is not a part of the graph of the actual parabola, but that is to help me to graph it. So the vertex is on that line. And if I want to find out where the vertex is, I just have to find the f of negative 3. Well, the f of negative 3 is 2 times negative 3 plus 3 squared minus 8, which gives us negative 8. So h is this number right here, negative 3, and k is this number right here, negative 8. That hk from the original description, hk, in this case is the point negative 3, negative 8. We could have just taken that directly from the function, negative 3, negative 8, for h and k. Now, once we have h and k, we can plot it. So negative 3, negative 8 is here. And that is an actual point on the parabola. From there, you just want to go through and find at least 2 other points that are actually on the parabola. Well, we were asked to find the axis of symmetry, the vertex, and the intercepts. So let's go through and just graph the intercepts. Alright, so let me see. So to find the intercepts, we're going to have to plug zeros in for x and for the function value. So let's see here. If I want to find, for instance, the x-intercept, or could be plural intercepts, then what I would have to do is I'd have to let y, or the function, the entire function, equal 0. So that's 2 times x plus 3 squared minus 8. Can solve this equation. We can add 8 to both sides, plus 8 on each side, and we would get 8 is equal to 2 times x plus 3 squared. We can divide both sides by 2, which says 4 is equal to x plus 3 squared. And in this case, we're looking for a number x plus 3 whose square is equal to 4. There's 2 such numbers. X plus 3 is either equal to positive 2, which is the positive square root of 4, so that if you square 2, you would get 4, or x plus 3 is equal to negative 2, because negative 2 times negative 2 also gives you positive 4. So either one of those could be the number x plus 3 that we could square and get 4. So I need to solve both. I subtract 3 from both sides here. I'll get x equals negative 1. I subtract 3 from both sides here. I'll get x equals negative 5, which gives me the 2 ordered pairs, negative 1, 0, and negative 5, 0. Those are my 2 x-intercepts. So now that I have the x-intercepts, let's see. That's negative 5, 0, and negative 1, 0. So negative 1 zeros here, negative 5 zeros here. And there I have the two other points that I would need to graph this parabola. I also need to know the y-intercepts. I know the x-intercepts are negative 1, 0, and negative 5, 0. Those are my x-intercepts. And this is the vertex. And now I just want to find the y-intercepts. So let's see, the y-intercepts. So to find the y-intercept, I'm going to find the f of 0. Just plug 0 in. So that's going to be 2 times 0 plus 3 squared minus 8. 3 squared is 9. 9 times 2 is 18. And 18 minus 8 is equal to 10. So I get for free the point 0, 10 as the y-intercept. So the y-intercept is the point 0, comma 10. So 0, 10, I can plot that point 2, and there I can connect the dots there. As you can see, in this graph, the point 0, the point negative 3, negative 8, negative 3, negative 8 serves as the lowest point on the graph. So negative 8 is the minimum. Negative 8 is the minimum. Let's look at one more. So let's take a look at this one. So once again, x minus h squared times a plus k here. This is the function. And I see there that h in this case is 5. Or you could just set x minus 5 equal to 0 to see that the axis of symmetry is at x equals 5. So the axis of symmetry is over here. And the vertex is the point 5, comma 6, because k is 6, so that's 5, 6 is the vertex. This is the axis. 5, 6 is here, and then we can find, if we so desire, the intercepts. Let's see. So we have 0 is equal to negative 2/3 times x minus 5 squared plus 6. Well, let's see, the x-intercepts, well, we could subtract 6 from both sides to get negative 6 is equal to negative 2/3 times x minus 5 squared, in which case we could take the square, or we could multiply both sides by 3 actually. So we could get negative 18 is equal to negative 2 times x minus 5 squared. And then we could divide both sides by negative 2. So that means that 9 is equal to x minus 5 squared. Well, if x minus 5 squared is 9, that means that x minus 5 is either equal to 3, which is the positive square root of 9, or x minus 5 is equal to negative 3, the negative square root of 9. So one of these tells me that x is 8. That's this one. The other one tells me that x is, let's see, what's that, 2? So we have 2 points, 8, 0, and 2, 0 for our x-intercepts. Let's see. So I got 8, 0, and 2, 0. And the y-intercept. So the f of 0, the y-intercept. Well, let me see. To negative 2/3 times 0 minus 5 squared plus 6 gives me negative 25, negative 5 squared is 25. 25 times 2 is, or negative 2 is negative 50. So that's negative 50 over 3 plus 6, which is 18 over 3. Alright, so that's 32 over 3. A little bit less than 10. It's like negative 10, negative 10 and 2/3. So 0, comma negative 10 and negative 10 and 2/3. All right, let's see. So negative 10 and 2/3 is somewhere up in here. So we have our downward facing parabola. And it turns out that this value here is actually the maximum value. So just like this one, negative 8 was the minimum y value. In this case, positive 6 is the maximum y value. 6 is the maximum. All right.